Hi and welcome back. We've got a challenge for you sports lovers out there. This one's called Ranking NBA Teams. You are given a string with results of NBA teams. See data in the sample tests section below. They have an example string here. You can see it's team names followed by scores, and each game is sort of separated by a comma. You know, you get one game, comma, then the Knicks played the Hawks. They give you their scores right after their name. It's that sort of format. A team name is comprised of one, two, or more words built with letters or digits, so that's good to know. Consider somebody like the 76ers in their name. If you're not careful and you're just looking for numbers and assume all numbers are scores, you end up interpreting possibly this 76 as a score. You can run into trouble there. So given a string of results in the name of a team, your function will return as a string the name of the team followed by basically all their stats for the list of games that you were provided. You got a number of wins, number of draws, number of losses, points for, points against, and then they have a sort of ranking system. I believe this is similar to hockey. You get 3 for a win, 1 for a draw, and 0 for a loss. So you'll have to calculate that. They give you the specific format that they're looking for. You wouldn't put team name, you'd fill that in with Clippers or 76ers or whoever. And then W equals, and then the actual number of wins. You keep that going. Scored is like points for, conceded, points against. And then this points is that standings thing. So you don't really need a separate field to track this. If you have the number of wins and draws, which we already calculated back here, you can say number of wins times 3 plus number of draws times 1, or just number of draws, right? So they have some remarks. The team name, empty string, should return empty string. So there's a good case to check for. If a team name can't be found in the given string of results, you will return the text, this team didn't play. The scores must be integers. If a score is a float number, you'll return error float number, the concerned string. You won't really return that. You'll see if you look at the tests below, it'll be the problematic text that you actually encountered. So they give you some examples to make sure you fully understand below. Feel free to read through those if my description here wasn't clear. You can see Boston, Celt. Celt isn't a team, right? It should be Celtics. And yeah, here's an example with a floating point number. And notice this is the text. They give you the actual score that blew up. So yeah, they try to complicate things by throwing in possibly some floating point numbers. You can be guaranteed that their tests are going to do that to you. So I think that's enough to get going on this one. Be sure that you pause as usual and give this one an honest attempt. And then when you're ready, come on back and we'll go through one solution, my version, but there'd be many ways. All right, so we'll get into it. First things first, I think I'll handle that really simple case, right? Where the team name is empty. And like in the past, sometimes I rename these variables just to make them, at least in my mind, a little easier to work with. So we can check for empty team name. We know string has is null or empty. Team, that means there was no team name provided. And in that case, they told us simply return the empty string, right? So we wouldn't want to do a bunch of complex processing, right? And then later on check for this simple case. Wouldn't that be really wasteful if we went through and processed all these texts and calculated stats, or tried to, and then only to just return empty string if the team was empty? So let's take care of that first thing. Okay, so if we survive past that statement, then we know that we don't have an empty string for a team name. Okay, looks like we're lined up there. So, the non-trivial case. And what I like to do in these cases to start, you just kind of step in a little bit. I'm not going to solve this entire problem in this method. The method would be very long and it's sloppy. So sometimes I'll write out comments with the major steps to solve the problem, or I'll even write it out and I'll pretend that I already have methods that do most of the work, and I'll call those and then make sure it flows and it covers everything. Then I'll actually go and implement those methods. You can do it that way too. So we'll try something like that. One little bit of work, we noted that this is an example result sheet in the test section. We've noted that each game is separated by a comma. So we can take that result sheet and separate those into a collection of games, right? We can say string games is equal to the result sheet. And we know strings have this split method where we can give it a character and it will return an array of tokens where it splits the string based on this character. Commonly, you'll see the space character or comma, if you're dealing with a CSV file, comma separated variable. So there, we split by commas, so now we have a bunch of strings in an array that will all read like this. First game, Clippers, Mavs. Second, Knicks, Hawks, We've got all those, and we can process them one game at a time, which is nice. So I'm going to eventually make a game result class, but for now, to keep things simple and just look at it from the very high level, which is what we want for our top level method, I'm just going to assume that class is already implemented. And it's going to be a game result. And a game result will have two teams that played. It'll have scores associated with each, and you'll be able to tell who won and who lost, that sort of thing. That's the idea behind the game result. So imagine I have something like that right now. We'll call it game results. And we know we gotta initialize that. And I'll make it as a list. And then what would you do if you had this nice class that described individual games? We could iterate over that collection, right? And sort of check for a specific team. We could search for a team. When we find game results corresponding to that team, we can accumulate stats for them. But for each of the games, right, we could say for each string game in games, and we'll take our game results, and the list has an add function, and we can add the game to it, right? So now we have this list of game results that are, each game result is initialized by a string like this, and then within the class itself, it can kind of parse this little bit to get team names and scores. So we'll get there. This is just supposed to be high level. We just step in a little bit at each layer, right? And then our sub methods, we step in a little bit more. And that's a good way to design things. Okay, so at that same kind of idea, let's say we had this magic class called team stats. And there was some great method we could use that would take care of accumulating the stats for us. Accumulate stats for a given team, right? We're going to search, and it's going to have game results to operate on, right? That should be enough information. I've got all the game results separated into separate games, and then I have a team name. And you can imagine how something could use those two pieces of information to tabulate stats. The stats class could define the fields for those stats. And simply at the end, you're left with returning stats. Let's say I override the toString method, and that will give us the string result that we want. And I'll override this to get there. So before we've actually implemented anything though, you can really see the overall strategy here. This method itself is very small, right? We handled the trivial case and we got out and finished right away if that were met. And then, this kind of flows like how you might talk about going about solving the problem. Separate all the games. You have a collection of them. You're kind of scanning each game to see if your team is in there. And if it's in there, grab the relevant information, compare scores, note wins and losses, that sort of thing. So it's pretty easy to read and understand. But we do have to implement this so it actually works. So we'll head on to that next step for now. To start, we should probably make the game result class. Maybe we can start there. That'd be a good place. So I'll make a separate class for that. Public class game result. And for our game result class, I will create a constructor for it. You can see when we added the games to the collection, and I did this wrong, right? Because the type of the list is game result. I can't just add a string. So let's say new game result game. It'll take the string as for its constructor and then give us the game result object, which we need in the list. So sorry about that. We'll make our constructor here. Public game result, and we know it takes a string game. And then to make that happen, what do we need to describe a game result? Well, I think we need teams and scores, essentially. So I'm going to make a couple fields to store those. And for this problem, I think I'm going to set them up as public properties. And then we'll be able to access them easily outside the class. List of string, we got teams. And I can say this, get private set. And what these do is basically say, notice the private accessor is only applied to the setter, which means if you want to modify this, nobody outside the game result class can do that. Since I left this one open, I didn't qualify it with a private keyword. It means people outside the class, you can think of it like public, right? They can access this field. And let's make one for scores too. Except for these won't be integers, or I'm sorry, strings, they'll be integers. Okay, so first things first, in here I'm going to initialize these in the constructor, new list of string, and same for scores, new list of int. Okay, so now they're initialized, we can work with them, we can add to them. So similarly how we split by the common to get individual games, to get the individual tokens in a specific game like I have highlighted here, notice everything's separated by a space. So I'm going to do something like string tokens. Oops. String tokens is equal to game split by space. So this is going to be an array that has Los Angeles Clippers 104, right? Etc. Team. Okay. So now we're going to want to go over these tokens to sort of construct what we need, right? We can say string token and tokens. And I'm going to make a helper method here just so I don't make this game result constructor too long. I'm going to separate it out into another method. But the general strategy will be something like this. If not process token, you could think of that like something went wrong. There was an error. Maybe we hit that floating point number that they warned us about. Something like that. Token team. And then if that happens, we should have an error message field too. Let's do that. And I'll make that as a string, public string error message. Private set, anyone can look at it, but only this class can modify it. That's what we get with the get private set. So if that happens, we're going to say the error message will be the problematic game itself. We saw that with the example of the floating point. They wanted the game that had the bad data in there as the ending part of the message. So I can just say the error message is equal to game, and then we'll break out of this loop of processing tokens, right? Because once we've errored out, there's no sense in continuing with the loop if there's any more data present. So like imagine LA Clippers was 104.7, right? Do we need to keep reading Dallas Mavericks 88? No, the result's going to be you're going to error out with that floating point error. So you just kind of short circuit and break out of there. Okay, so we have this magical method, process token. Let's go ahead and implement that, because we have to make everything that we use. Private, it returns a bool, right? I used it as a Boolean condition where if it will note whether an error was encountered or not. So, got the name there, and it's going to take a token from a game, and it's going to have a team name. And I'm going to pass this might be new in this series, we're going to pass this by reference, which is an important thing to understand in programming in general. You got these two ideas of passing by value and passing by reference. When I pass by reference, it's referring to the actual parameter itself. When I say string token without the reference, it can make a copy of the data that I pass in when I call the method. So the method's called up here, right? Process token. This would be a copy of whatever token we're on in the loop. It'll copy it. So what's the consequence of that? If you modify something that's a copy, you don't modify the original, right? I wouldn't contaminate this string if I modified token. I could say Les Angeles, but the original is not modified if I did that. Where if I take something by reference, I modify the actual parameter itself. I'm not working with a copy. And that's useful sometimes. So I'm going to do it that way because I will sort of construct the team as we loop. Because it's not simple. Team names they can have spaces in them, they can be multiple words, they can have numbers in them. So I'm going to sort of construct that. I started with the team as an empty string, and we'll build it with each version of the loop. You can imagine it. At first it turns into loss, and then I come through again and I add Angeles to it, and then I add Clippers to it, and then at that point I might have a full team name. So that's kind of my strategy there. Okay, so one thing outright that I know I can do to make this simple, if I encounter a decimal point anywhere in this game string, right, that's bad. There's no periods in team names. I'm going to use that as my cue that there's a floating point number present, even though technically if the input came in as Los Angeles Clippers dot, this statement would still fire. So if they had a weird test case like that, we might get a bad result. If you don't like that, you can modify. You don't have to follow with me here. But I'm going to keep it simple. We've seen contains before, right? If a string contains, and we can pass it a character. So right here, I'm going to use that as my check for a floating point number. And at that point, I'm going to say return false, right? We were returning a bool. That means, hey, the token was not processed successfully. False indicates an error. And remember, when we encountered that error, we're going to simply grab the whole game text and set it for our error message. Okay, good. So if we survive this, there are no floating point numbers, is my assumption. You can make yours more robust again if you want. We're going to start out with a score. We'll initialize that to 0. Okay. And then sort of what I'm going to do is check for whether the input is numeric or whether it's characters. And so if something's all numeric, I'll be able to parse it into an integer. We've used int32 parse or try parse to convert strings to integers, and we know that operation will fail if something's not fully a number. So consider that 76ers, right? The 76 is numeric, but the ERS at the end is not. So if I try to parse that, it'll come out false. Even though there are some numbers present, that entire token cannot be interpreted as a number. So that's how I'm going to differentiate between numeric values and text values. So I'll say bool success is equal to int try parse, and we're going to take the token, whatever token we're on while we're looping, and outscore. We've seen the out keyword is used with the try parse. If you want to review that documentation to see that, go ahead. But we set up a score variable, and now we have this out keyword that the score is going to come out of this method, right? It's going to take the token and try and produce an integer from it, and we passed in a sort of reference to our integer there. So if success, that means the token was a number, right? And if not, it was text. That's basically what we're dealing with. And so what I think of this as is we come through the first loop, we get loss, and we're gonna, each time it's not a number, we're gonna sort of build the team name in place, right? So I'm gonna say if string is null or empty team, right? That means nothing has been added to it yet. It's still that empty string that we started. I'm going to say team plus equals token. So this is going to set it to LOS on the first iteration of the loop. And then otherwise, it's going to essentially be the same thing, but we need a space in our team name, right? For the next token. Plus equals space. Actually, let me do it this way. And I can say token. We've used that before, so it should be good there. So the only difference is we're prepending a space, so we don't get LOS capital C. There's LOS, or I'm sorry, A, not C. There's a space between Los and Angeles as we build up this team name, right? Each time we're adding another word for the team name. But at some point, right, we're going to hit a number value that's going to represent their score. And when you do that, you know this team string that you've been building up is complete and you have a full team name. So at that time, we can do something. We can say our scores, add the score, the number that came out of this token. And we can also add the team that preceded that. Teams add team. And then don't forget to clear the team value because we're going to read the second half of the score, right? Then we're going to go into Dallas Mavericks. So the next iteration is going to get Dallas. The next one's going to add space Mavericks. Then we'll hit a number again. We'll know the team name is done. So it will set Dallas Mavericks as the second team. And it will see the 88 as the second score. And it'll be at index position 1 in the scores list. So that's the idea there. And then finally, if you survived all processing, we'll say return true. We successfully processed those game tokens. So I think that covers us there. Return true. Yep, we got our error message if we need it. Game result class should be done. We'll go on to the next challenge. How about we go back and do that? We could make our team stats class. That would probably be the next logical step. So game result, public class, team stats. Okay. So for team stats, we remember from the instructions, we'll make fields for all these. I'm going to initialize, I'll make my constructor here, just has the name of the class. Public team stats, we'll initialize it with a name, the team's name. And so we'll set, I'll make a field called name. Because the stats correspond to an individual team, right? So what kind of fields do we need for a team? Public string name. Same concept here. We're going to leave them publicly accessible, but not, well, some of them will allow modification because we're going to have that accumulate stats method, right? But for the name, there's no reason to let people switch the name of the stats. That would be chaos. So we won't do that. But, you know, you can imagine the rest of them. Wins, draws. I'm going to add a games played field too. And you'll see why that's helpful. So of course, it'd be an integer, not a string. We're going to have some other integers. Integer should be fine for us, but in theory, remember, if you were, I mean, no, you'd have to be looking at tons of seasons, but in theory, if you were processing humongous input over many years, integer might not be enough at some point. I don't know if that's realistic for a basketball example, but you know what I mean. Be aware of your types. Wins, losses, draws, and we'll do point for and points against. Points for, points against. And then we're going to have something to be able to pass along that error message we were dealing with earlier too. Okay, and remember we don't need the standings, a field for standings, because it's easily calculated from the number of wins and draws. So I think that covers all of our stats. Then we know we have to override the toString method the way I used this class above. One thing to help with that standings calculation, I'll make a couple of constants. Public static read-only int, and I'll call it points for win. The convention is to capitalize constant variable names. We can say points for draw. Make that equal to 1. And those will read a little nicer as we can reference those fields. They're easily changed in one place. So the magic happens in the toString override. Let's implement that. Public. We're using the override keyword because toStrings implemented for all objects. If you don't, you can not add the override keyword and they'll give you a nice warning, and then you can go ahead and fix that. But it'll just tell you like there's kind of a default implementation for toString that is often not very helpful. So, and if you didn't want to mess with that, you don't have to use toString. You could just say call your method print or something that's not already defined, or you know, write stats, or I don't know, something that you like. So anyways, we need to print out the output in that defined format they're expecting. So I'm going to start with that nasty floating point case. I'll say if not string is null or empty, and this is the error message. And if that's the case, it means an error message is present. We have a problem. Let's say return, and this is how they defined it, error float number exactly. And then they wanted the text of the game, right? So I'll throw my error message in there. We saw previously that I just put the game text in there, so that should work. And then I made that games played field, right? If games played equals 0, that's sort of my catch that the team didn't play, right? We went through all the games and we never found the team name, and that'll be implemented when we do the stat accumulation. But that's how I note whether a team name wasn't found, just so you know. And then we can say return the team name, and they had colon this team didn't play exclamation mark. We don't need that. Okay, this team didn't play. Good. And then if we survive these two error cases, they want the actual stats. So we'll say name, and they wanted a W equals wins. And what they separate by semicolon. D equals draws. Probably L equals losses. Then we have scored, which I called points for. Conceded equals points against. And I'm just gonna start on a second line there just so to keep everything visible. Points, these were their standings, and we can say wins times points for win plus draws times points for draw. And you can say that multiplication's worthless, but in theory, if you adjusted your stats where, say, wins became worth 5 and draws were worth 2, you know, then it's already in place for you. But if you don't want to put it there, you can just simply add the number of draws. So that gives us our general output with the toString method there. So we'll go back up. We implemented game result. We have this class now for team stats, and it will return a string when we tell it to, a result. So left is this method, right? We have to implement that. So for accumulate stats, I'll keep this in the NBA class that they stubbed out for us. I'm going to mark it as private because nobody in this class needs to use it. It's our sort of private sandbox for making calculations. It's static, right? I don't have to create a NBA object to use it. I don't want to. It's not necessary. All it needs is a team and a list of games. So accumulate stats. We said string team, list of game results. Okay, so once we finish this, I think we're good. We're going to create a team stats object for tracking stats for a team, right? Whatever team was passed in for us. And remember, it took a team name to construct one of these. We defined that. Now we're going to look over each game result. I'll call it game in results. And we're going to process each one of these. So as we look through these, we're going to check that error message field, right, to see if we encountered any of it. Remember, when we constructed a game result object, it did some processing of its own. It found the team names and scores, so it would have set the error message field there if we had encountered something bad like that floating point. So let's check for that, if any of those were set. If string is null or empty, game error message. If it's not null or empty, that means there was a problem encountered, right? And so what we want to do is sort of forward that error message to the field in our stats class. And then break, right? Because that ruins the whole thing. As soon as you get that bad condition, there's no sense in processing the rest of the game. So we already know what the result's going to be. It's already defined. So break out of the for loop. Stats already has its error message set. When you call toString on it, it's going to see that and return the error message. So provided there were no errors encountered, we can say, what do we want to do? I'm going to make another helper method here to log an individual game for a team. And we'll use the same strategy of taking the team stats by reference. So we're not using a copy and modifying a copy, right? We want to accumulate this object itself. We want all the results to be processed together. So I'm going to have something like log game for team. This is what we want to do. We want to pass ref stats, because otherwise if we're using a copy, right, it's going to modify it for one game, then it's grab a new copy and modify it for the second game, just one at a time, and that's not what we want. So it's going to need the game data. We're going to need those teams and scores, and then I'm going to pass it a team index so it knows which team is the one that we're examining, because in any given game there's two teams, and we need to know, hey, do we want stats for the Clippers or the Mavericks? So I better set that in team index equals game. Remember, the game result class has a teams list, and I can say index of, basically grab that list, there's only 2 items in it, index of team, and that'll tell me which team I'm making stats for. I'll say if team index greater than equal to 0, because index of, I think, returns -1 if it doesn't work. We shouldn't have that happen, but you could throw an exception if you wanted to check for that. Maybe we will if we run into trouble here. Alright, so again, assuming everything turns out right, we're just going to return the accumulated stats, right? So now we sort of delegated some work to another task. We could do it all here, but it will make this method really big, and we don't like that. So we'll make a log game for team method. Again, private and static. Users of the NBA class don't even need to know about this. So I'll say private static, and it'll be void. It doesn't need to return anything. The sort of returning, if you will happen by modifying this stats class. Log game for team, right? And we want our data structure that holds the stats, taking this by reference. And then we want a game, and we want the team index. Okay, so remember we had that games played field for the stats class, so I can say stats games games played, right? Because the team index was found by virtue of this function getting called was greater than or equal to 0. So I'm going to increment the games played, and this is helpful. Once I get at least one of these, I know the team was found in the list. So next, let's get the opponent indexed, right? Because we need to index their team name and score too. I'll call it opponent index, and we can set that equal to team index plus 1 modulo 2. And this should work out, right? Because team index is going to be either 0 or 1. There are only 2 teams. So if it's 0, then team index goes to 1. Modulo 2 is still 1. So you get index 1. And then if you look at it the other way, where team index is 1, 1 plus 1 is 2. 2 modulo 2 is 0. So opponent index gets set to 0. And it should work for both cases there. And next we can grab the team scores. So I'll say team score is equal to game scores at team index, and then we can say opponent score equals, if you want I'll put this on another line, or you can keep it on the same line if you like. So opponent score would be game scores at opponent index, right? Okay, so we got scores for our teams. And then let's mark the wins, losses, draws, points for, points against. If team score, nothing fancy here, just if else kind of thing, is greater than opponent score, then we're talking about a win, right? Plus plus stats wins. Else if team score is less than opponent score, what would that be? We would say plus plus stats losses, and else if it's not, that means they're equal, right? If it's not greater or less than, we'll say plus plus stats draws. So that handles the basic stuff, and then let's get those points for and points against. Points for plus equals, remember we just keep accumulating those, team score, and then stats points against plus equals the opponent score. Okay, yeah, and there's nothing to return. We're just sort of loading the data into this stats data structure each time. It'll get these numbers incremented. So we took care of that method. Think we're close here. We might be ready to run. Let's go ahead and give it a run. We'll run the test first. Probably made some kind of error. Bad array declared or on line 10. What do we do here? So line 10 split string games result sheet. Clear measure. Oh yeah, sorry. I started typing that in another place in the code too. The brackets go with the data type, right? Dumb mistake. Okay, list access wires are not allowed on static constructors on line 20. What did I do? String team. Static. Oh, I don't think we need a return type. I have to say void. Even when you don't return anything, you gotta say the return type. So let's see if that fixes it. Type or namespace list could not be found. Sure, we didn't bring in. You should know this one well by now. System collections generic to get that list type, right? Because we didn't define list here. That's something built in for us. Cannot implicitly convert type void to team stats on line 17. Void to team stats. What did I do? Return. Oh, yeah. So, okay. I get it now. I shouldn't have made this void. This, remember, we made a team stats object here, and we return it at the end. So I meant to return stats. For this, log aim for team is void. But yeah, we're building up stats objects here. So that makes sense. It was fair for them to complain. Those types didn't match. Line 100, argument 2 must be Okay, so I missed the reference keyword. Let's go down to line 100. Yep, remember when we made process token, we can look at it. It takes the team name by reference. If we don't, it's not gonna, as we go through each loop and are building up that team name, it's gonna be messed up. So we don't want that. We want that to persist. What else do you have? Hibernate. Team stats could not be found. Are you missing a using on line 23? Class team stats. Go up to line 23. Okay. Not be found. Oh, yeah. Ooh. Team stats, not teams stats, right? So we'll run that. We passed all tests, which is good. And that was the simple round. We'll hit attempt to get the larger collection. And there you have it. We passed. We nailed it. So this time I didn't add any print statements. If you had them for debugging purposes, this would be a good time to go ahead and take those out. But I think I'll submit mine like this. Go ahead and fire that off. And there we have it. And as usual, I'll go through and review some of the ways other people did it, try and learn something, see calls and techniques that I'm not used to, and try and figure out what they mean. It's a good time to review and learn. So you go ahead and do that too. And then thanks for watching. I'll see you in the next video.